Okay, we're now going into our panel format. Hopefully it'll be very highly interactive and very informative at this point. And so what I'd like to do is, if the panelists are ready for this, maybe some tough questions from the audience here. So let me now turn to the audience. Are there any questions or discussion items or other observations or statements that anyone would like to make to get this thing going? Okay. Okay, I will start. This 200 years from now really intrigues me. Okay, and one intriguing thing about it is that it's very hard for us to actually say the actual year. And I was thinking about it, and it's amazing I had to even think about it for more than 2 seconds, but I did. I think we're talking about the year 2220. Oh. 2220. Okay, 2220. So for the year 2220, when we're doing things like downloading our brains to our robots or stuff like that, where do you think fog is going to be? Fog and edge and cloud. I mean, is it still going to be relevant, or is there going to be some other paradigm that'll be applicable?
Well, you're going to have pretty good data rates, I suspect, to be able to download your consciousness. Or essentially, I think the kind of things you're talking about is where you can essentially act like you're somewhere else without being there by sort of projecting yourself into some other entity. So that's going to take some pretty high data rates, I suspect, but I'm not sure, to be able to do that. And it's going to be a lot of local network connectivity, a lot of, and then broadband connectivity as well. So it's hard to say exactly what we need to make that happen. I don't know. You're from Cisco. You can talk about it.
I think everything as we know it will be dead and gone and be forgotten. And only shows up in history books. And I hope fog will be somewhere in that history book. And because I think it will be important, I think it is becoming reality as we speak already. Yeah.
Well, it happens that as I mentioned, I started involved in fog through working on BCI, brain-computer interaction. So I would like to take a kind of postulation about what would happen. Okay. Actually, I don't think it takes that long. The thing that we have been talking about is that if we can extract some of your brain state, very raw brain state, we're already trying to do that. And some of the people are like Facebook. That reason that they put so much money into the BCI is because they really want to see whether we can using the brain state as an additional attribute, just like your gesture, just like your facial expression, to augment your communication with other people. And if you consider that if you are in a meeting.
What do you mean by brain state?
Yeah, whether you are happy or you're angry or you're actually not paying attention.
You don't mean like whether you're in New Jersey or Nevada or?
Yeah. And if you put all these things, to augment your common gesture, things, and put us into a room, I think that kind of or put us into a family network, you will find that our interaction, our relationship will be dramatically changed. Yeah, and I don't think it takes that long. I think we are already on that. But let me actually even go beyond that and then see whether our audience would like to respond to that. I once have written a very short paper, not really published in a very good place, talking about thing and human symbiosis. And I think if we are doing this, and also not really need to have brainwave, but just have more natural human interfaces, and then our interconnection with things, with the sensors, through exactly this continuum that we are building, I think this is the best way to do sustainable living. We can find a more efficient way to use energy, to do transportation, to get things done. The thing and a human being, and in the context of our society, can really start to be symbiotic. And I want to explore that. And I think, once we create this infrastructure, I think we will see a paradigm shift. That's what I feel, yeah.
Okay, Nan?
Yeah, I think you're looking at me, and obviously I'm very opinionated, and I want to take advantage of this opportunity and just throw a few more challenges in a way. When it comes to cloud computing, you mentioned about the brain-computer interface. I have been very much entrenched in the data bank aspect from the point where I felt that there could be commonalities among brain images, brain recording across the board. Okay, this is a big assumption. So we're still looking for answers of that. Okay, if you have, why do you want to put all the brain EEG data or image in the cloud? Because you want to share the data. But the fundamental issue, let me finish, okay. The fundamental issue is whether your brain image has any correlation, any similarity to Tom's, to Tao's, or to Doug's. Okay, we made this assumption. We look for the patterns. We assume when you are feeling happy, then your EEG, we're dancing on your frontal lobe or whatever. But is that the real situation? So 200 years from now, I would think that individualization of brains could be done in the cloud, and there is a place for that. Okay, if that is the case, what we're doing today might actually be just the trial, an error. We're going to err a lot before we come to a recognition that individual's brain is different, and there will be a society or a cloud or, like you say, galaxy, someplace where we can all just flourish based on our own brain functions. So the question is whether there's commonality, whether there's a place for the cloud to store all the images or the behavior records of your brain, or whether it should stay on Earth or on the edge or on your cell phone. You can only record your own stuff in your cell phone. So, yeah.
Could I, Nan,
Yes.
that's great. Yeah, what comes to mind is Star Trek and the Borg.
But I would like to use that analogy, but I hope that we are not going to that down the evil part of it. First of all, let me clarify what I'm saying. You raise a very, very good philosophical question. Is that our perception, is there any commonality between our perception? Perhaps what you call blue, the very sense that you call blue, is not blue in my mind. If you convey your whole information to my brain say, oh my God, this is yellow. Are we seeing the same? Or this is an
or you're colorblind. It doesn't matter.
Right. Yeah. So the thing that we are, at least what we are in the brain community is trying to do, is actually like building a language. It's not building a direct channel. It's building a language. So that's the reason why we say feature extraction. We know that when you get excited, when you feel that you say that you get excited, your brain somehow have some signature, but your signature is very different from mine. Exactly. That's the difficult part of the BCI. But at least we can say that now we know that you are excited, not only by what you say you are excited, but by some indication from your neural circuitry. And when I say I'm excited, I also have a model to detect that, my circuitry is excited. So it's like building an additional vocabulary, additional symbols that allow you to communicate more than just saying the word. I think at least for now. But ultimately, where should we go? It's a very interesting thing.
200 years from now, who knows? It's what, 5 generations from now?
That's why it's so interesting.
And by the way, I really believe technology are going exponential, no matter whether you believe in singularity or not. And I think 200 years from now, we really cannot imagine.
So I'm not sure it'll bring an end to war.
We might not be here.
So I'm not sure it'll bring an end to war or people fighting, but I do believe that these technologies, if combined with ways you can authenticate where it's coming from. That's kind of like things like even pulling in blockchain, or what's beyond blockchain in terms of how do we know that we're really getting the right stuff from somebody, but that has the possibility at least that people will have a better understanding of each other, and for instance, which will help them in terms of negotiating and understanding what each one needs and where they're coming from. So that's going to have some kind of a beneficial effect, I think, on human societies, and hopefully it will allow us to do the big things that we must do if we're going to continue to support the number of people we have on the Earth with a certain amount of resources, go out into outer space, develop new homes, in the solar system and beyond, Yeah, we're talking 2020. We are talking Star Trek here.
2220.
2220. We're talking Star Trek here, So we need those faster than light engines.
Yeah, warp speed.
Warp speed, indeed.
Okay, other comments? Other thoughts? Go ahead. Wait, microphone, wait.
Oh, she's got.
How long do you think it will take to lay all the necessary infrastructure for fog and edge?
The earlier products are already there. So you'll see commercial products from all major companies already. They may not name them fog. Some of them may not name them edge, but they're there. They do one of those three things I mentioned in different forms, in earlier forms. So that's the good thing. That means that it's real. That means people think they're important. That means people are devoting resources to it. Major players, not just sort of playing, they're devoting resources to it. On the other hand, the real potential of this thing, I think is going to take years to realize. I think people realized how significant this is to me. I think for over the past 15 years, it would be the era of fog and edge computing. Just like over the past 15 years, it was cloud computing. And as people realize that cloud computing is having difficulty cloud computing alone sort of is having difficulty supporting a whole lot of newer requirements, right? So this actually, fog computing actually comes in and fill this gap. So that's my view. On one hand, you have real products already. On the other hand, the potential is so great. Yeah.
And one thing I was going to say in my talk, if I had been able to use my slides, is that part of what's enabling that, interestingly enough, I think, is the fact that we're not doing the Moore's Law scaling anymore. We're having to be more clever in terms of computing architectures. And now we're doing a lot more accelerators, as you saw in the keynote earlier, special purpose processors that are going to do certain things, which really fits into doing things on the local level, where you have these accelerators working. So there's a really interesting connection between memory and storage, because that's what I do, but the processing and the whole networking in terms of making this work and where the data is going to live and where we're going to process it. And the other part of it is, of course, is that in order to save energy, in order to save time, people are going to want to process data closer where the data is. So memory and computing are moving closer together one way or another.
I agree with Tao. Certain kind of implementation is already here. We don't want to name people's product, but they are already here. But on the other hand, I would say that IoT, Internet of Things, would not have its full potential being exploited without fog and edge computing. And the two enabling technology, I think 5G indeed is one. And the other one is our good old internet. Think about that. If every home gateway, it's now not only a gateway, but a computing server, as I said, it's completely doable right now.
Yeah, it has memory, it has processing,
Yeah. And every, cell phone base station would have the same, micro data center in it. And we can run whatever you want to run on them instead of in the cloud for all your mobile app and whatever. That's where it would take off. And that would happen in a few years' time. very soon. Yeah, I know that there are companies already in Taiwan that are building that kind of server, that kind of home gateway that I'm talking about.
And I know that there are companies that are building storage devices with more processing capability in them. For instance, Samsung had a smart SSD with a Xilinx FPGA running an ARM processor, for example.
So these things are not research. These things are, they are motivated by the companies. The companies are building them, yeah.
Okay, it's just about 6 o'clock. If somebody does have a burning question, now's the last chance.
I have a question.
Okay.
So the view on edge is if I have something I want done, some sort of computing task, it's either going to go to some node somewhere that has the resource that will be spread across multiple nodes in order to give me the power I need to take care of that task. So if it's going to go across multiple nodes, then it must be some sort of standardization would be required to do that. But my other question is, do we have the programming languages in place now, or are we going to develop them that allow us to break up a task and then move it across different pieces of hardware which aren't the same, but which would have the ability to contribute to the end task that I'm looking to have completed?
They aren't in the same place.
So could you?
Okay, that's the reason why we're doing standards. And if you talk about the most crucial component in our reference architecture or the future functional architecture, there are two things. One is the distributed management part, and this is the one that we are now focusing on. We know that if we don't have the distributed management and orchestration infrastructure, this cannot be scaled. We can do it, basically, one data center, start the star architecture, one data center, a few dozen, edge nodes, they all directly connect to the data center. But if you really want to have a distributed network, distributed management and orchestration, first one. Second one, unified connectivity or unified messaging system. Basically, you have to have the same format, you have to have the same carrier, but then you can convey different kind of semantics, so-called, okay? Luckily for that, actually we are not that far away because, we are converging in web service already. People are using, the RESTful API that comment, we are using JSON or more elaborate, XML. We just have to move forward a little bit, okay? My feeling is that in terms of programming language, first of all, we cannot dictate it. People won't listen. People will choose their language, and then they will become popular. And I think, Python, in some form Java, they may already be the choice. People are using that. People are already using it. What we would like to do, then that is a little bit of a R&D question, is the programming paradigm. We are familiar with doing parallel programming, but this is pervasive computing. This is microservice-based, loosely coupled thing.
Keeping things synchronized.
Yeah, it's a high-level design. That high-level design, are we going to evolve something, like evolving object-oriented?
It's almost like an internet computing is what.
Yes, it's internet computing, but then,
velocities.
yeah, when we develop object-oriented, we meet a certain need. Now we have this new need. What is the corresponding paradigm? That is a good question. And I have to frankly to say I don't have an answer to that. Yeah.
Anybody else?
Go ahead.
Oh, no, I was going to say, when you're talking about that, I was almost thinking it's like you almost have to have a vision of the computing you're doing, especially if you're distributing a bunch of nodes that are connected together that can deal with failures, like the internet, so.
Put it that way, there are people more and more looking at so-called, no matter whether they call smart object or ambient object, they're more and more looking at no matter whether it's data or program, we all call them resources, first of all, and they all pair that up with metadata to define their execution profile or behavior. I think this is the first step. And then you can think of orchestration is actually the complementary step. You have to have a script to design that.
And multiple paths for
Yeah, I mean, just a start. I really don't know.
Yeah.
How may
Here you go, Tao. You go.
No.
From the last.
So as we said, in my mind, fog computing is really this distributed way. You distribute a whole lot of resources to places, and then you try to use them collectively, try to compute. And I hear two camps arguing about how much of standards you need in that paradigm. Right? I hear people say, well, I'm not going to distribute my computing resources. I'm not going to send my tasks to somebody else's computer. It's going to be all my computers. It's going to be all my servers. So in that case, and I can keep all of this under the wrap. I do whatever I want. As long as the interface to the user is standardized, I'm okay. And that's moving ahead. You hear sort of a lot of companies are doing that. And so on the other hand, there are arguments that says, okay, if we have a standard way of distributing those resources and using them collectively together in a standard way that helps people, sort of multiple players come and play, for example, different hardware, different software systems, and can come in play. So that makes it a little easier. But my observation today is that those two camps are sort of are going simultaneously ahead. And maybe the proprietary path is going even a little faster because it's a little easier for them to do things, right? It doesn't need consensus by a lot of people. So I think we're at that very interesting crossroad now. And in terms of what's going to happen from a standards perspective.
Can I add one more thing? I think the time is up already. We talk about standard. I think right after the standard, there will be regulations. When we have, all these distributed things and across, national application, vertical commercial boundaries, regulation. But I have no idea how that would proceed. Yeah,
Okay,
there would be a huge need of regulation.
By 2220, we'll know. Okay, and with that, I want to thank the panelists for an excellent job on the panel, and also, of course, the audience. And thank you all for hanging in here, and see you next time.